Hope you're charged because we are continuing with another great session. Please welcome Alex Shershebnev, Head of ML and DevOps at ZenCoder. In this session, he will walk us through how to actually build and code AI coding agents from concept and working influence.
Thank you, and hello everyone. Let me share my screen over here. Right. So hopefully you see the screen. Now, yeah, indeed, I work at the company called Encoder AI. I am officially head of MLOps and DevOps, but I also double as DevRel, and in general, Dev ask me anything like I like to call it, because you need to wear a lot of hats when you're working at a startup. So today I will be talking with you about AI coding agents and in general, how they work, how to implement them, and then how to use them in your everyday life. And I must say, it feels every time I do this online, it feels a bit weird because I don't see people's reaction, I don't see people's faces, but hopefully you will at least laugh at some of the memes which I have in the slides. Now, before we dive into the general AI agent world, and throughout the presentation, I will be switching interchangeably between two terms, AI coding agents and AI agents, just because all the things which I will be showing today, they can be applied both to AI coding agents specifically, but also to AI agents in general. And my examples will be about coding, of course, because, well, we are all developers here. But again, as I said, all of those things can be applied in general to AI agents, and you can reuse the same code I will be showing today to essentially, for example, build an agent that would, I don't know, book tickets for you, or I don't know, buy something or book a hotel, whatever. Now, recently, you might have seen a lot of different headlines saying that developers will soon be replaced. And for example, here there's a quote from Mark Zuckerberg from a couple months ago saying that AI will replace mid-level engineers pretty soon. And there are sort of there are obviously more than two, but two main reasons behind these headlines. First of all, the models are getting better, and for example, here you can see the Gemini 2.5 Pro, which was recently released by Google, and it of course beats all the previous models on the benchmarks. I highlighted here the main three coding benchmarks, which usually are used to assess the quality of the models specifically for coding. Now, the problem with this is, well, while models are getting better, if you look at the actual benchmarks, so for example, either polyglot is essentially just a list of tasks where the model needs to fill in a class or a function, just essentially several lines of code. In reality, this is not always the case. So when you are working on a real project, occasionally, or maybe not occasionally, you need to modify more than one file. You need to modify tens of files. You need to implement. You might even need to modify multiple repositories, just because you have the microservice architecture, you have libraries, so you might need to update the library and then go ahead and the services update the way this library is called. So basically, while benchmarks are good to get a sort of first impression of the model, of the quality of the code the model produce, it's not always applicable as is to the reality of the coding. And then the second part, the second sort of underlying part to those headlines of developers being replaced is AI agents. So, and that will be our main topic for today. And the agenda is, well, first we will go through what agent is. Then we will code the coding agent, and then if the time permits, we will also briefly talk about how that would affect the future of development and how it will affect the future of, I guess, work or work style of developers. And essentially, at the end of the presentation, you will be able to code an AI which might might replace you in the end, in a couple of years, or maybe not. Maybe not. Who knows? And we will, as I said, if the time permits, we will talk about this at the end. Now, what is AI agent? Well, you can define AI agent essentially as a software that performs tasks on behalf of the user. And this kind of sounds like any software, right? Any software performs a task, and even the current coding assistants, they can generate code for you, they can generate docs for you. So essentially, you give them the task of, I don't know, generating a new search bar or whatever, which is the task, right? And they perform that task on behalf of you. The difference of agents is that they follow several. And of course, you can generate tens of thousands of lines of code and then spend several days on debugging it. Now, the difference in agents is that they sort of follow specific design principles or design patterns, if you will. First of all, they can use tools, and those tools can be pretty much anything. That could be a web search, that could be debugger, that could be code execution. So essentially, any tool agents are provided, they can use it. They can also do planning, so they don't just blindly output something for you. They don't just blindly start answering you. They can come up with some plan. They can follow that plan, and then they also can reflect on that plan, which is the third pattern, reflection, right? So agents don't just simply plan. They can also critique themselves or each other. They can reflect on what they already done. They can reflect on their plan, and they can adjust the plan based on that reflection. And of course, there is also multi-agent collaboration, which we will also see in the coding demo. But basically, multi-agent collaboration would allow multiple agents interact with each other, critique each other, work together, plan together, basically do anything to help agents fulfill the task on your behalf. And you can think of agent as essentially a Roomba vacuum cleaner, right? So the software itself that is running on the vacuum cleaner, on the robot vacuum cleaner, is an agent. Now, if that agent was only able to sort of point to the dirt patches on the floor, it wouldn't be very useful, right? It would be pretty much annoying. Now, instead, Roomba has, for example, tools. It can use tools like brushes. It can also do planning through room scanning. So basically, it first uses a tool to scan the room, and then it does some planning. And apparently, ChatGPT thinks that robot vacuum cleaners walk in this weird spiral-like patterns. But yeah, it is what it is. It is what AI generates, basically. Well, with Roomba, of course, there is no multi-agent collaboration unless you count this as sort of multi-agent collaboration. But maybe in the future, the robots, of course, would be able to talk with each other, and maybe Roomba would be able to talk with, I don't know, another Roomba in another room, and they will be able to collaborate to clean your apartment better. Or maybe it will be able to collaborate with some other robot. Now, what does all of that has to do with the coding? Well, to answer that, let's first look at what developers spend most of their time on. Now, I will give you a couple seconds to think about. Think what you spend most of your everyday working hours on. And spoiler alert, it's not drinking coffee. Yeah, if you are thinking about fixing bugs, if you are thinking about clarifying the requirements from the client or something along these lines, you are pretty much correct. And in general, all of those things can be combined into this blue understanding segment. Essentially, what this means is in order to perform the task, you first, of course, need to understand the requirements. You need to understand how the existing code works. You need to understand what you need to do, and so on. And this is what most of the what most of the time is spent by developers, according to this research, which was done 10 years ago, but I think it still holds truth until today. And as you can see, actual editing of the code is only 5%. Yet the current generation of coding assistants, they focus mostly on these 5%, completely ignoring the rest of the time of your everyday life, right? And now if we sort of juxtapose these to the design principles which we just saw for the agents, we will see that, for example, for the tool use, of course, you have editing, spending time outside of IDE is also potentially a tool use, right? You can, I know, do web search, you can use debugger or whatever. And of course, UI interactions are also a tool use. Again, you might use browser to check how your front end looks, or you might use I know, some IDE tools to debug something, right? Then, of course, planning is an important step in our everyday life. And to do proper planning, you of course need to first of all understand what you are planning for. Right? You need to understand the task. You need to understand the requirements. You need to understand how to write the code and so on. And maybe you also spend some time outside of IDE while planning, of course. Then reflection also requires a lot of understanding from you. So, you can't really reflect on your plan. You can't really reflect on your work without understanding what is going on, and without understanding the requirements and so on. And of course, multi-agent collaboration, right? We usually work in teams. We interact with our peers. We can talk with them. We can collaborate with them. We can plan together. We can critique each other and so on, hopefully in a peaceful manner. So essentially, all of the things which we do in everyday life, they can be juxtaposed to the agentic patterns. And basically, if we want to get a much better coding assistant, right, we need to have coding agents which are able to help us in our everyday life, in our understanding of the project, in our understanding of the requirements, and so on. Now, with that, let's finally do some coding. And all of the code that I will be showing today is available on this repository over here. You can either scan QR code or go through this link, basically. And the way I structure the live session is I like to go through several stages, and hopefully not those stages, right? But basically, what I like to do is I start with the baseline, sort of some simple use case on top of which we will then progressively iterate by introducing more and more agentic concepts in our demo. And by the end of the coding session, we will have a multi-agent system that will work together to perform some task on our behalf. Now, with that, let me switch to my Jupyter notebook. Let me actually first start it, of course. All right. So let's start with the baseline. And for the baseline, I will be using, let me zoom in a bit, of course, for you. As a baseline, I will be essentially just using the regular ChatGPT. And I'm assuming all of you already use AI in some form, right? And you probably already know what the responses would be from ChatGPT to those queries. But basically, over here, the code is pretty straightforward. I'm just connecting to OpenAI and sending a message to the model over here. And then I'm just returning the response. Now, as you would expect, the OpenAI model itself, it doesn't have any access to the real life world, right? So it doesn't have access to web. It doesn't have access to your local machine. So, for example, it won't be able to answer what is the response time for Google, right? So, it doesn't have real-time data or whatever. Check the current internet statuses. It might provide some help for you, like some commands for you to get this answer. So in this case, for example, it provided the command ping google.com. However, this is not really that help, right? You need to switch the context, you need to switch windows, and so on. The same goes if we try to ask something about our local system. So in this case, I'm asking what Python packages do I have installed? And of course, ChatGPT doesn't have access to my local machine. Again, it tried to provide some help, tried to provide some commands over here. So for example, it provided pip list, which is a correct command, right? But still, it is not able to do even those simple tasks, yet alone any more sophisticated task of, for example, I know, running the code it generated. And of course, the models themselves have this sort of cutoff based on the last knowledge update. And for example, here in the case of ChatGPT, the last knowledge update was in September 2023, which is essentially almost 2 years ago. And of course, at that time, Python 3.14 wasn't even in the plans. Well, I mean, probably it was in the plans, but there were no information about it. So of course, ChatGPT doesn't have any knowledge about Python 3.14, and I would imagine even not even about Python 3.13. Of course, it tried to, I think, answer some generic answer, like typically include some improvements, such as, and then it tried to, well, not hallucinate, but try to invent some generic answer for you, which of course also is not very helpful, right? So let's see how we can improve that by giving the agent or by giving the LLM the ability to use tools. With that, let me switch to a second directory called basic agent. Now we are again using the same ChatGPT. Again, I'm using the same OpenAI framework over here. Now, on top of that, I will be using what is called React framework. And React stands for Reason plus Act. And essentially, this framework instructs the LLM to follow several steps in its thinking process. So first, it should start with a thought. And thought could be, given the query, I need to perform some action, right? I need to do a web search, I need to run some command, and so on. Then the second step is an action. So action is essentially what LLM chooses to use, chooses to perform, right? To execute as an action. And this is essentially returned as a response from LLM in a specific format. We will see a bit down below. Then the LLM will pause, and this essentially is for action to be executed and the response of that action to be returned to LLM for analysis. Then there is observation step where LLM analyzes the output of the action and decides if that information is enough for LLM to answer the initial user query or not. And then hopefully it is enough, and then it will give you the answer, or if not, it can go through the same loop again. So it goes through to the thought process, thinking, okay, I got some of the information, I need some more, I need to run a different action, and then this loop sort of goes on and on until LLM decides that it has all of the information to give you the answer. Let me run the whole kernel here in the meantime. And essentially, the way you can implement this is through this system prompt, which essentially instructs the LLM to do what I just described. Right, so you run in a loop of thought, action, pause, observation, and then you need to give the answer. Use thought, use action, and then we also provide the LLM with available actions. So in this case, I give the LLM 3 actions, ping, and I provide also an example of how to call the ping command. So it would need to return ping, semicolon, and the website. The same goes with the bash tool. So basically, I allow the LLM to call any bash command, to execute any bash command on my local system. And of course, there is a web search where basically it can do any web search to answer the user query. There is also some examples of the session, just for LLM to be more aware of what is expected. So there's a question like, right, for example, how many islands make up Madeira? I live on Madeira, so it's a sort of small Easter egg for that. The thought from LLM should be that I should do a web search, Madeira. Then it should return the action web search Madeira. Hopefully, the web search itself will return the proper answer for LLM to observe, and then based on the output of the web search, the LLM will be able to answer hopefully correctly again. Now over here, I have the same function to query the model, right? It gets the input, the messages, and then it sends them to the OpenAI, in this case to OpenAI. I also have here a few actions, or a few tools, which I just added to the prompt, namely ping, which basically, returns the ping for the website. I have bash tool, or bash function, which will execute any bash command locally on my local computer. And there is also web search, pretty basic or naive implementation of the web search, and we will see later some examples of more advanced web search. Let's also test the commands. As you can see, ping gave us pretty high number for the Google, surprisingly. For Python, this looks correct. I indeed have Python 3.12.6. And then for the web search, we searched for Python 3.14. It found this website, which basically is changelog for the Python 3.14. This is the content of the website, and then based on the content, somewhere below, there is a lot of information. Looks, where is the answer from LLM? Oh no, that's not yet the answer. That's just the content. Okay. So the functions work. That's good. Now, just for our simplicity, we also combine them into this sort of dictionary where we have the match from between the name of the command and the actual function which we need to execute for that command to happen. And then we have this query function, which essentially just implements a loop of thought, action, and observation, where we start with a message of with the initial user prompt and system prompt, which you've seen before. And then once we send them to LLM and get response, we need to check if the LLM decided to do any action. And in that case, it should match this regexp of action, semicolon, and then just follow some word, and again, semicolon, and then the whatever action argument are expected. If there is an action, we will match that action to a list of known actions, execute this action, and send the observation to LLM. So we will basically append the message back to list of messages and send these history of messages back to LLM to observe, and then decide if it needs to perform another action, or if it needs to if it has enough information to answer our initial query. So over here, I have the same query which we just seen before. What's the response time for Google? Right. So in this case, LLM decided that it should check the ping response and perform essentially ping command. It returned this action, right? Post for observation. In the meantime, we ran the ping, got in this case looks like a better result, surprisingly. And then in the second loop, LLM decided that that information is enough to give us the answer, and it gave us the correct answer, a bit rounded, but yeah, it's fine. The same goes with the access to local system, right? So again, if I ask what Python packages do I have installed, it first decided to run the bash command piplist, which makes sense, right? So piplist gave this long list of packages I have installed, and then based on that, the LLM, in this case, LLM decided to be lazy, and it just mentioned a few of the packages, right? Well, I indeed have many packages installed, but still it was able to essentially access my local machine and perform some action on that local machine indirectly, right? So it didn't connect directly to my machine. It just called an action. So it wasn't direct connection from OpenAI to my machine. It was just sort of proxy. But still, it was able to get information from my computer. And then for the Python 3.14, again, it decided to do a web search, Python 3.14 new features, which makes sense. It got the data from this website, again, a lot of data. Let's scroll all the way to the bottom to the second loop. And indeed, I would imagine that much information was enough to answer our question. And over here, it gave us a nice summary of the changes based on the web search, right? So there are apparently several PEPs which are coming in Python 3.14, some additional improvements for the build models and so on. So basically, it was able to update its own knowledge, if you will. All right, it's no longer limited by this knowledge cutoff, which was, if you recall, September 2023. Now it can access any up-to-date information, like all pretty much in real time. So we can, for example, even ask about the current conference. When is DSC MENA in 2025? Let's see if LLM will be able to give us answer. It decided to do a web search, which makes sense. And yeah, I guess doesn't see any specific dates for some reason on the website. Well, yeah, there is still some improvements to be that needs to happen for the AI, but well, at least it was able to answer us the question about Python 3.14. Now that's of course nice, right? We already have the LLM or the agent prototype, which can run some commands, which can have access to our local environment, which can have access to the web search, which already opens up a lot of potential opportunities in what we can achieve with this simple agent. But it would be pretty tedious to always implement all of these commands, all of these actions on your own. And then, if you were to, for example, use, instead of this web search, some third-party web search tool, which somebody might also implement, most likely it will be used in a different output format. It might even use a different input format. So it would be quite a pain to try and add new tools to this simple agent, especially if we are talking about third-party tools. Luckily for us, several months ago, in November 2024, Anthropic introduced what is called MCP, Model Context Protocol. So let me switch back to presentation for a second. And Model Context Protocol is essentially a standardized protocol for giving LLM access to tools, giving LLM description of those tools, and the way for LLMs to call those tools. It is based on JSON RPC 2.0, and I will show some example on how the tool looks in a second. And why is it needed? Well, it basically just standardizes the interaction between MCP client. In this case, it could be an IDE, it could be LLM directly, and so on. Basically, any MCP, any tool which wants to call which wants to use some tools, right? And then we also have MCP server, which essentially is just a server or a tool which can call either local resources. So you've seen, for example, Bash tool, which called local commands. MCP servers can also call remote resources through RESTful API, for example, or whatever way of communicating there is with those remote resources. So essentially, anything you can code to interact with environment, either local or remote, can be converted to MCP server. And then MCP protocol itself is essentially just tells LLM what tools it has at its disposal and how to use them. So in this case, for example, I have an example from GitHub MCP server. And in this case, the tool is create branch. So it will create a new branch in GitHub repository. So this is basically a description for LLM to better choose the tool. And then there is also an input schema, which basically requires owner of the repository, right? The repository itself, name of the branch, and from which branch to create a new branch. So essentially, it just shows to LLM how to call the tool and what kind of information it needs to provide for that tool to successfully execute the action. And there are a lot of servers already available for you to choose from. So there are, of course, some tools, some MCP servers, which Anthropic provided themselves. But I will show also how to write your own servers, and you can find a lot of third-party servers available online, either on the official Anthropic's repository, model context protocol /servers. And I think there are around like 300 servers already available over there. So you can see they range from something like, I don't know, Exa, which is the web search. There is also Cloudflare, ClickHouse. So basically a lot of tools which you might use in everyday life, like Grafana, for example, right? They can be accessed through MCP, either from your ID or from your Jupyter notebook, as we will see in a second, from Cloudy Desktop or whatever else you use to interact with your LLM. Now let's see how we can actually create our own MCP servers as well. So for that, let's go to this agent with MCP directory. Now, Anthropic, in addition to providing the protocol itself, they also added a few SDKs in different languages, Python, Java, JavaScript, and so on. Again, you can find the reference on their website, modelcontextprotocol.com. And with Python specifically, they have this nice fast MCP class, right? Which some of you might see, for some of you it might resemble a fast API essentially, which I guess in a sense indeed follows the same principles, the same flow as fast API. So what we do here is we define this fast MCP server called bash. And then we have this function, which is decorated with the decorator mcp.tool, which basically converts this function to an MCP tool. And in this case, it is a pretty straightforward function, right? It just executes the bash shell command and checks output and then returns said output to LLM or to the client. Right? But of course, you can imagine essentially whatever you can code here, whatever you want to code here, it can be converted to MCP. So instead of running the bash command, it could be API call to Jira. It could be some local file system operation and so on. So essentially, again, whatever you can code, you can convert to MCP essentially. Then for our client to use the MCP, we also need to have this JSON, which essentially just describes how to call our MCP server. In this case, I have playlist of MCP servers, and I have only one for now, which is called the bash. And the way it is called is through command Python with the following arguments, right? So it's essentially just Python and the name of the file. But of course, you can, again, as we will see a bit later, you can call those servers in a lot of different formats. It can be Docker image, it can be npm package, and so on. So essentially, it would depend on how the tool itself, how the server itself is defined. Now let's see actually these tools in action. And for this notebook, I will switch to Anthropic Cloudy model. The reason for that is Cloudy models initially were better trained to follow these MCP tools, but recently also actually OpenAI adopted the MCP protocol as well for their own models as well. Now, let me run again all the cells, and we will go through them one by one in the meantime. So what I'm doing here is, first of all, of course, I'm loading this Anthropic client, right? I'm loading also MCP client as well, and the client session. I will show why we need it in a second. So we basically define over here an MCP client, which just connects to the servers. So the main code you need to be concerned about is over here. Essentially, what it does, it connects to the list of servers based on the config, which we just seen based on this JSON config. So essentially, it just gets starts the MCP server, gets a list of tools, and then pulls all of the list of all the tools into a single list. So essentially, as you can see here, in the end, it will give us sort of this nice printout of it being connected to the server with the following tools, and we will see the list of tools available for each server. And then the second part is processing the query. So essentially, of course, we will start with a user query. Then, based on the decision from LLM, it might decide if it wants to use the tool, or if its response is just a plain text. We will diverge based on this decision. So essentially, based on the message, we also add the list of available tools into the input to LLM over here. So we collect all the tool names from the sessions. We append them as a list of available tools with name, description, and input schema, as you've seen just previously in the case of create branch tool. And then we send all of that to Anthropic. And in this case, as you can see, it also has this argument for available tools, which you can use to provide the list of tools available for LLM to call. And then, based on the response from LLM, it could be either content type text, where it's essentially just a response, a plain text response from LLM, or if LLM decides to call the tool, it will respond with content type tool use, and then also the name and the input to the tool. And in this case, we will basically just go to the specific server with those inputs, call the tool, and then return the response of the tool along with the previous messages to the Anthropic LLM, and get hopefully a correct answer based on that observation, right? So over here, we are getting the response from the tool, right? So calling the tool basically, and then appending that response to the history of messages, and all of that history is then sent to Anthropic, to the Cloudy. And over here is just a nice helper function to have the chat loop. So basically, until we type quit, the LLM will wait for our query. Now let's see this in action. So we will start with just a single tool, bash tool, our own self-written MCP server. So what it essentially does, it allows us to execute any bash commands. So we can ask, for example, list all files. And this hopefully will make LLM decide to call a command ls, for example. Let's see what it actually will decide to call. Yeah, indeed, I decided to call ls-la, which makes sense. And it got us a list of files in the current directory, right? So there is also some extra information from Claude, which we didn't ask for, but Claude likes to be over helpful. So let's tweet this one, and let's see more tools in action. So let me show first the JSON config. So what we have here is we of course have our own bash tool MCP server, which we just created over here. We also have a fetch tool, which essentially allows you to fetch, well, not you, it allows LLM to fetch any URLs, any content from URL. We also have Brave Search, which is essentially just an AI-based search engine. And as you can see, we are running it in Docker in this case. And then we have a file system MCP server, which essentially gives the LLM access to our file system on our local machine. And in this case, it is ran as npm package, and this is just to show you that you can run those MCP servers in a lot of different ways, essentially, right? Either through Docker, Python, npx, or whatever it is written in again. Now let's see how this extends the capabilities of our LLM over here. So we loaded the full server config. We got connected to all the servers. So we now have tools for file system manipulation, right? So we can read files, write files, edit, create directories, so on. We can do a web search. We can fetch URLs, and we of course have this bash command as well. So this would allow us to, for example, ask to create new file called hello.txt with content hello world. Let's see what Claudia decides to do with this query. And yeah, so it decided to call the tool write_file, which makes sense, with the path hello.txt, content hello world. Let's see. Yeah, we already have the file over here, and it is indeed hello world inside this file. Then we can of course do one of our previous queries, right? So what's new in Python 3.14? And in this case, hopefully it will decide to do a web search and give us the answer to our query. It might take a bit longer because usually input from web search is pretty long, as you've seen in the previous notebooks. But yeah, indeed, it decided to call a Brave search tool with Python 3.14 new features release input, and it gave us sort of quick summary of all the new features, the release status, development timeline. So basically, some the main sort of points from the web search. So yeah, essentially, again, with the MCP servers, you can extend the capabilities of LLM to use any tools you might want it to use. And again, as I've shown in the slides, there are a lot of MCP servers available to essentially interact with different tools, and we will see some examples also later. Now, so far, those tools were just essentially, well, tools, right, or applications. So we use some local bash commands, we use some web search, but either way, they are still, all of them were essentially, well, tools, right? But you can, of course, imagine the same tools being, instead of just an application, being also agent itself. So we could have an agent which can have as tools different agents, then potentially those agents can also have as tools different agents, and so on. So basically, we can have this sort of hierarchical structure of agents being able to call each other, being able to interact with each other through the tool use, essentially, right? And let's, in this case, let's implement this sort of simple structure of multi-agent collaboration. So we will have, well, we will of course have the user. We will have the supervisor agent, which you can think of as a product manager, right? We will have a few agents with which supervisor can interact directly, and they can also respond to supervisor, and through supervisor can also interact with the user. Now, in our example, in our demo, the agents, this agent 1, agent 2, and agent 3, they won't be able to talk with each other directly. They will be able to do that only through supervisor. But of course, you can imagine them being also able to talk with each other. So for example, I know, let me open the demo over here. Basically, we will have few agents, namely front-end, back-end agent, and DevOps. So you can imagine, for example, this agent 1 being front-end developer, asking something the back-end developer for some, I know, API reference or whatever, directly, not through supervisor. But for the demo itself, we will only allow them to interact through supervisor. So our sort of virtual product manager agent or supervisor will be the main point of contact both for us and for the agents at its disposal. Now let's see how we can implement this. And let me actually run the whole thing again in the background. But I will be using for that another sort of layer of abstraction, another framework, namely LangChain and LangGraph. And the reason for that is, well, you of course can implement all of the interactions between agents on your own. It is essentially just a sort of asynchronous calls and structured input and output on the very high level. But when this can be abstracted by a third-party library, why not leverage that, right? So we will use a LangChain LangChain's tools. We will have shell tool, Brave search, file management, and human tool, and we will build the multi-agent graph using LangGraph. So again, I'm using the same model, Claude 3.5 from Anthropic. And as I mentioned, we also have a few tools, pretty much the same tools we had before. Shell tool, right? So bash tool essentially. We'll have web search. We will have file system tool. And what is new here is the human tool, if you will. So essentially, what this will allow AI to do is it will allow it to ask humans back, right? Or humans as an user who sent the initial query. So it will be able to ask for any clarifications. It will be able to ask for any requirements and so on. We will see that in action in a few seconds. So that's our tools, our tool belt. And then we also need to define our agents themselves, right? And as I mentioned, we will have front-end developer, back-end developer, and DevOps engineer. And we will have our supervisor. Now, you don't need really to sort of humanize them in a sense, right? You don't really need to make them front-end or back-end developer because, of course, it is still the same LLM in the background, but it is always helpful to sort of focus agents on specific task, first of all, through system prompt, but then also I would imagine that, for example, front-end developer and the back-end developer, they might need different set of tools, right? So front-end developer might need to use tool to get, browser access, right? To check the UI. It might need to have a tool for calling Figma. At the same time, backend developer doesn't need to call Figma. It needs some other tools at its disposal, and of course, DevOps engineer might need a completely different set of tools, like calling Kubernetes, Grafana, or whatever, right? So in this example, still they will all have the same set of tools, but in sort of a real life scenario, again, I would imagine them having different tools, and again, you don't need to explicitly name them the same roles, but still it is good to focus them on specific tasks, right? So as I mentioned, we have our supervisor tool, a supervisor agent, which we essentially just instruct as such, right? So your supervisor, you have the following workers. It will have 3 workers at its disposal. It should respond with which worker to act next. So basically, it will just delegate. It will choose whom to delegate the next step, the next action, and then each worker will perform the task. In the end, once the supervisor decides that the task is done, it will respond with finish. And then, of course, available tools, again, as I mentioned, bash tool, search tool, file system tool, and human. So over here, we are defining our supervisor node, which is just a system prompt, and then the structured output from the LLM. Pretty straightforward, and we have this final node for the finish. Then let's also define our executor agents, if you will, right? So we have, as I mentioned, front-end agent, back-end agent, and DevOps agent. And they all will be essentially the React agents. You already seen the React framework, so they will just follow the same pretty much thought, observe, act principle as we've seen before. It's just nicely sort of hidden from us thanks to LangChain. And again, we will define our LLM, which is the same Claude. We'll have the list of tools, and the system prompt for the agent is it is a front-end developer in this case. So create front-end applications. You can work with a backend developer, and you can ask backend or DevOps engineer for help, or you can also ask for clarifications from the human client. And this is where our human tool comes in, right? So it will be able to ask us as a client any questions. The same goes with the backend engineer and with DevOps engineer agents. And all of them, as the only sort of next node, all of them have supervisor. So they can only go and talk next with the supervisor. They won't be able to talk with each other. But of course, you can imagine here, backend engineer also being able to talk with front-end engineer or agent, right? And then we define our graph, right? So we have the starting node, which leads to supervisor. We have the supervisor node, and we have 3 nodes coming from the supervisor. And let's also see the graph. It is indeed looking as expected, right? We have supervisor, which can talk with front end with our other agents, and the agents can talk to supervisor, but not with each other. And for the task, I'm instructing this multi-agent system to build a website for the conference. It should have several pages: intro page to submit the talks, page with submitted talks. Front end needs to be in React, backend in REST API. Submissions to be stored in Postgres. Create a Docker file, Docker Compose, so on, and you can ask also human client point verification. And then we just essentially run this graph over and over, and we'll see what it comes up with. As the first step, supervisor decided to call front-end developer, which makes sense. Then, in turn, a front-end developer decided to ask us as a client for some details. So, some details on intro page, what information, submission, and so on. Now, as a good client, as a good project manager, we will ask what we'll tell whatever the good client will tell you. I don't care. And basically, then LLM will try to come up with something on its own. So in this case, he decided to create a basic version that we can enhance later. Spare. But we'll start with the front-end application. And this can take some time because NPM installation can take some time. But let's see. We already have the conference website directory with the package.json. It might take again some time to, we already have node modules. So it looks like something is running through npm install. Yeah, so npx create command is being executed, and then npm install is also being executed over here. Okay, so packages are installed, and then it already started to output some code for us. So we have some CSS and JavaScript files, and it will basically go over and over by creating the files, updating its content. So in this case, it is updating home.js with some information. So we decided that the conference will happen in Silicon Valley, I guess, on January 15 to 17, 2024. Okay. And then, it will take some time for those agents to come up with something. We can follow them, but for the sake of time, we won't be waiting for them to finish. As you can see, they already started. Front-end agent is already creating a bunch of files. At some point, I would expect it to pass on to backend developer. Usually, backend developer also likes to ask something from the client. Let's see if it decides to ask something in this case. Yeah, so looks like it needs to connect with the backend developer. Could we connect? I don't care. I have meetings, as a good product manager would answer to such query. And it will then proceed on its own, hopefully, with some follow-ups. Let's stop this multi-agent system here. And for a second, go back to the slides. Now, implementing all of that is also, of course, always fun. Tinkering with the prompts, tinkering with the tools, and seeing how the agents can interact with each other, what they can come up with, and so on. But of course, you don't always have time for that, and it's always nice to be able to use all of those agents in your everyday life without any effort, right? And this is where we will switch to the product of the company I work for, Zencoder. And basically, it is a bunch of agents which you can use in your IDE, in VS Code or JetBrains. And we will do pretty much the same exercise of creating the website for the conference in Zencoder. We will see that in action, and then we will use agents to do some follow-ups there as well. And in this demo, in this section of the demo, we will be using several MCPs, namely time, and well, you will see why we need time in a second. We will use Docker, of course. We will use Grafana. We will use Git. We will use GitHub, and we will use Slack to communicate with us. And every time I get this message on Slack from the agent from Zencoder, it sort of reminds me of this meme. And generally, you can, of course, implement the agent, well, not to message you, but instead message the PM. But let's see how it looks in action. So let me switch to VS Code over here. So for the sake of time, I already did two first sort of actions, right? So I already defined the MCPs. So I have over here the MCPs for time, for Git, for the Docker, for Grafana, which I still need to update over here, and for GitHub. The Slack MCP is defined outside of that file. This file is specific for the project. So these MCPs would only be available in this repository. But I also defined a few MCPs outside of that. So basically in the global setting. So I have Slack here, and well, we won't need Kubernetes today, but it's just for my personal use essentially. And I already ran two sort of starting commands over here. So I asked the agent to check out branch app. It didn't find it initially because I didn't have it in the repository. I only had main. But then it decided to, okay, I need to create a branch and need to check it out. And we can see that we should be on the branch here. We are on the branch app, right? So all good. And then I gave the agent pretty much the same task as I did to our multi-agent collaborative system in the Jupyter notebook. I asked it to build a website, again, several pages, and so on, create Docker file, pretty much all the same prompt I did use in the Jupyter notebook. And it did come up with a lot of different files, and it took some time, several minutes, so that's why I prepared it in sort of ahead of the conference. But we can see a lot of different files being created both for the front end. So there is some front end directory with the files. There also should be some backend somewhere as well. There is Docker file, Docker compose file. There is some README, which is always nice. It also posted me a message as I instructed it to do for every task. Basically, when you are done, send a message to Alex Shershebnev in Slack, which it did over here in the end, right? And there is a summary. So basically, in the end, we got a lot of different files. Let's see the project. We have the backend with just a main.py, a Docker file. We have the front end with a bunch of files. We have the Docker compose over here, right? So let's actually try to start our website. See how it looks. Okay, so it should be available, I believe, on local host 3000. Okay, great. So as you can see, it also says DSC MENA. If you look at the prompt, I didn't instruct the agent to create specifically DSC MENA. I was able to deduce this from the name of the repository, which is called DSC MENA. Let me zoom in a bit. And the website, well, this sort of like, I guess, the first rough iteration. It still says 2023 because of the knowledge cutoff, but we can submit a talk, we can view the talks, right? So let's try and submit one. Talk title, talk one, Alex, Alex at alex.com, and description, right? Submit talk. Okay, talk has been submitted. Let's see. Yeah, we got it here. Let's submit another one. Talk to call Bob at bob.com and description. So we should have now 2 talks over here. Great. So all of that works. But again, 2023 is not the current year, of course. For some reason, Telfo thinks that the conference is happening in Dubai in December, which is not the case. The topics also don't really match correctly, and there are still a lot of things to improve. And let's ask our agent to basically iterate on top of what it created and update it. So let's first ask it to update the time. Let me stop the Docker files here. Check the current time and update time accordingly in the website. Also, let's pull information from the actual DSC MENA website. Also pull info from DSC MENA website and update info on our website accordingly. Right, and let's see what it will come up with. I also am using coffee mode. As you might have noticed here, we have coffee mode. So maybe with this coffee mode, now the developers will spend more time on drinking coffee rather than understanding. We'll see. But basically, let's see. Try to fail to fetch the web page. For some reason, it failed. See if web search worked. Web search, I guess, worked. And hopefully, it will try to update the website correctly. Let's see what it will come up with. As you can see, it is going through several files to find which are needed to be modified to fulfill the request. And after that understanding, it will it will update to the current year. So our time MCP server worked correctly. It started to update. Let me close that one. Started to update the files. Changed the date. Changed. It's still December 10, 12 for some reason. Let's see if it will update it later. It pulled updates here. And of course, it will also send a message to me in Slack. So it got me a new message over here that did update the website. Let's see how it looks now. Restart our application. Compose. Build. Hopefully it will now look more up to date. Okay, let's see. Let's reload. Okay, so it is now 2025. Location is still Dubai. That's weird. Let's ask it to fix that. Check DSC MENA website online and update info on our website based on that. Let's see. Okay, web search is done. I hope the conference website is not blocked from AI tools. hopefully, but looks like it's fetching something from the web. Okay, fetching is done, and now it will update the files for us. All right, so the updated this part about sort of target audience, I guess. Updated the dates. Okay, now the dates are correct. It is April 10 today, and the conference is running from April 10 to April 12. Updated the topics. Nice. So I don't think we have anything about web development or mobile apps on this conference. It is mostly focused on AI, ML, and so on. Some update about the conference itself. All right. Okay. Updating some other links here as well. Okay, in the meantime, while it's updating, let's also actually add monitoring to our website. So let's run another agent in parallel. Let monitoring for the backend. For the backend API using Grafana. Yeah, coffee mode tends to open the files, and the focus of the window switches to the files. So that's why I'm occasionally starting to type in different window and Prometheus, right? So let's basically ask the agent to add Grafana and Prometheus, right? Pretty standard tools which are used for monitoring. Let's run the agent in coffee mode as well and see what it will come up with. Okay, so yeah, indeed, I guess we need to update the requirements. We need to update the Docker compose. The backend Docker file potentially needs to be updated as well. Let's see. So yeah, requirements txt needs to add new Prometheus lines. That makes sense. We need to also modify the backend to actually use Prometheus as well. Okay, some middleware. Nice. Okay, so far so good. Okay, metrics endpoint. Add in the actual data login, right? Some config files for Prometheus, some YAML coding, a bit of YAML coding, some Grafana dashboard. Okay, it will also actually create a Grafana dashboard for us from scratch. Nice. I would assume that it would be quite a long JSON file. That's why it's taken a bit longer time. In the meantime, we can check the other task, the website. Okay, I should have got a message. Yeah, so it updated the website, and indeed it pulled all the info from the actual real DSC MENA website and updated our local conference website replica based on that. So update location, dates, change the focus, some ticket information. Okay, cool. Navigation. So basically a lot of different improvements, which we will see in a second once the Grafana is also done. So we will be able to run everything together. So it updated the Docker file, Docker Compose. I think is also updated. Yeah, so Docker Compose now has 2 more services inside itself, right? For Prometheus and for the Grafana. It updated README, I believe. Yeah, some notes on the monitoring. Yeah, some URLs, very secure admin login and password, of course. And yeah, a Slack message to myself, of course, is also good. So basically, it's just a summary of what it created. So with all of that with all of those changes, let's try to run our services again. Wait for the Grafana and Prometheus images to pull. Hopefully, it will be quick. Yep. Okay, in the meantime, I think we have the Grafana at localhost 3001. So let's some error. Yeah, there is an error with backend dependencies. Update them to the latest versions. Yeah, looks like the Prometheus client is a bit out of date. So let's hopefully it will decide to do web search for updated versions. So let's see. Yeah, indeed it is doing the web search for newest versions of those packages. So it will hopefully be able to update the packages for us. In the meantime, yeah, so Prometheus client seems to be a bit out of date. Or rather, Starlet Prometheus is a bit out of date. Okay, let's see. It will be able to fix that on its own. If not, we will just remove the specific versions for the sake of the demo. All right, it's doing a lot of web search as well. We have a lot of packages, so I guess that makes sense. We close all the tabs here. Check the requirements. We do have 7 of them. All right, so it was able to pull all the info from the web to get the latest versions, hopefully. And let's see. Okay, so it's some updates on the SQL Alchemy. All right. I guess the latest version indeed, it did switch to 2.0, I see. So indeed, also needs to be some changes on the SQL Alchemy SQL Alchemy side of the code. Okay, and then the Docker file needs to be updated, I guess. Yeah, that seems reasonable. And of course, the Slack message, as always. Okay, in the meantime, I think let's try to run the build again. We can see the summary of the changes of the updated versions. Let's see if those versions will work together nicely. Looks like they are. Backend, I think, was built. Frontend is built. All right. We are live. Let's see the website now. All right. So the website now looks much more updated. All right. So 2025 AI and data science conference. Location is correct. Dates are correct. Topics, ticket information. Nice. So I think that are correct prices. Online tech tutorials. So basically all the information was pulled. And see, I think we still have the talks. Okay, there's a link to buy tickets actually. Nice. So we can buy the tickets. And let's actually also access Grafana. I think the Grafana is on the localhost 3001, our secure admin login and password. It wants to update. Let's not save it, and let's put another a bit more secure password. All right, so we got into Grafana. Let's see, we should have the dashboard, which was created for us. Indeed, backend API dashboard. No data still. Let's see, let's try to call some endpoints. Let's submit a talk 3. Alice at alice.com. Oh, we now have the list of topics. Nice. AI. Description. Mid talk. And we should have new talk over here as well. Let's see if we have the data. Come into Grafana. For some reason it doesn't. If there are any errors in the log of Grafana. Prometheus. Did Prometheus even start? I'm not sure. Okay, well, yeah, apparently, I guess there is some issues with Prometheus. We won't spend more time on fixing that. But of course, you could ask the agent just to run the Docker images. Again, we have the MCP for that defined, so it would be able to run the Docker image on its own and, well, check what's going on and fix that issues. But we are kind of running out of time, so we won't do that. We will just do one last thing over here. We will ask the agent to commit all the changes and create a pull request, and hopefully it will be able to do that. Let's see, commit and push changes, create a pull request. Okay. Added the files, committed them. Okay. Taking remote branches. Okay, parsing the git config to get the information. Okay. Yeah, so it can create a pull request, of course, without pushing the branch. That makes sense. Let's see. Git log. So it was able to commit the changes, right, from my name. You know, it's using my credentials, not some random, I don't know, root or whatever credentials. So you can take all the credit for agent's work. I don't think it created a pull request actually. Not sure what happened there, but yeah, we are already at the time. So let's quickly switch back to the presentation and talk a bit about the future of development with all those agents coming in hot in your IDE, right? And in general, again, I've already showed some headline. I already showed the headline quote from Mark Zuckerberg that AI will soon replace mid-level engineers. And in general, I would say there are sort of two sides on how AI will affect the future of development, right? So there are, of course, a side which thinks that AI will replace us all, not just developers potentially, but everyone. And it's a sort of meme time part of the presentation. And developers might be replaced, and maybe you finally will be able to follow your life dream of being a goose farmer, after 22 years at Microsoft or wherever you work. But then, of course, AI still can't train its own without the actual data. So there is at least this potential prospect of work where you will need to create data for AI. And of course, there is at the same time, if you've heard about the term vibe coding, there is also sort of not so nice part of vibe coding, which is you still need to understand the code, you still need to debug the code. So basically you can just at least for now, you can just let AI do all of your work. You still need to be able to understand the code. You still need to be able to read the code, write it potentially, and so on, and debug maybe. So in general, the way we as encoders see the future is AI is not a replacement, well, at least for now anyway. It is more of an assistant. It is more of a copilot in the true nature of the word, right? So essentially, you as a developer, as the data scientist, you will become more of a manager, right? Or reviewer of the work of AI. And essentially, you would have a lot of kind of junior or intern virtual developers at your disposal, whose work you will need to review. And for that, of course, you still need to be able to, read the code, understand the code, and so on. But basically, I think that in the couple of years, the developer's job would sort of transition into more, again, as a managerial style of work, where you would be just delegating all of the at least mundane or repetitive tasks to virtual developers, virtual agents. For example, I know writing unit tests, writing documentation, writing some boilerplate code, right? And you yourself would be able to focus more on high level or creative tasks, starting from architecture of your product all the way to the product itself, right? So in general, you as a developer or data scientist, you probably would need to get more business acumen, if you will, essentially trying to be more understandable of what the company does, what your company works on, what your product does, right? Because otherwise, you won't be able to properly review the output of AI assistant. And with that, few QR codes for you. On the left, you can scan the QR code to get started with Zencoder if you liked what you've seen on the demo. If you want to try us out, we support VS Code and JetBrains IDE, so in PyCharm, IntelliJ, Android Studio, whatever you use. And on the right QR code is a link to all my contact details. If you want to stay in touch, if you have some questions which you won't be able to ask now, you can connect on LinkedIn. Can ask any questions there. And with that, that's all from my side. I think we have a few minutes for the questions. I hope this is allowed on this online workshop. I'm actually not sure, but let's see if I can answer any questions. Okay, let me see. I think in the chat there are some messages. Coder to debugger, yes, indeed. Oh, yeah, as you've seen on the slide, wipe coder to wipe debugger, I guess. Yeah, it looks like at least some of the people like the memes. That's nice. It's always nice to see that people like memes. The presentation, I think it will be shared. I'm actually not sure. I will. I'm not sure if any of the event organizers are here and can comment on this, if the presentation will be shared or not, because I did send the link to the organizers to the presentation, so hopefully it will be shared. And just in case, I can bring back the QR code for the let me share the screen for the repository. Right, so this is a QR code for the repository. If you didn't scan it but want to do that, or if you want to take a screenshot or whatever, feel free to do that. Or you can just go to github.com/zencoderai and you will see all the public repositories there, including this code in the coding agents repository. Right? Thank you for the memes. You're always welcome. Connect QR. 1 second. Let me scroll over here. Here's the QRs for connection with me and for the Zencoder itself. Yeah, I hope you had a chance to either take a screenshot or scan it. Let's see. I don't see questions, maybe in direct messages. Nope. So is there any special questions? Okay, so I guess no questions. Then, well, yeah, again, you feel free to message me on LinkedIn through this QR code on connecting with me, right? We'll be happy if you give us a try, give our product a try, and of course, feel free to fork the repository and play around with agents. It's always fun. It's always interesting to see how they can automate your life, your everyday tasks, right? Not just the coding tasks. Of course, as I mentioned in the beginning, all of the principles can be applied to general AI agents as well. So again, you can ask them to book a ticket for you. Actually, on the model context protocol, there was a nice interesting server. Let me try to find it. So basically, it's not only about ClickHouse or whatever MongoDB stuff, there was also an interesting server. I don't see it. I don't see it. Oh, there it is. So basically, this MCP server would allow you to connect to Netherlands Railways API, and then you can check the real-time train travel information. So basically, you can ask questions like, when is the train coming from Rotterdam to Hague, or basically whatever you want to ask. And I would imagine again any websites like this which allow for API access. Actually, I think Flight Radar is also one of them. Yeah, you can actually connect to Flight Radar directly from your IDE and ask when is your next flight, or whatever you want to know about the flights right inside your IDE while you are coding the future product. All right, nice to meet you, Mariam. All right. Oh, there is a question. How do you update LLM with new information? That's a good question. So how do you update LLM? Well, you've seen the web search tool being used both in Jupyter Notebooks and inside the encoder. So that's one of the, I guess, fastest and cheapest ways to update its knowledge, right? Because it will be able to just do a web search. You don't need to retrain the model whenever new data comes in. You just allow it to search for that information itself, right? So, for example, in the case of my demo in the Jupyter, I had this Brave search tool over here, which essentially just allowed the LLM to search for any information it needs to search for. And if we are talking about some internal databases, knowledge bases, like Confluence, Notion, or whatever, you can also connect to them through MCPs. Again, there are a lot of MCPs for Notion, Jira, Confluence, whatever, right? And you can also pull data from your internal knowledge bases through MCP as well. And that way, LLM essentially will know not just general information, but also information about your internal documentation, about your internal systems. You would be able to update, to leverage that to get better answers. Okay, I see the presentation was shared. Nice, thank you.
Thanks, Alex, for taking us behind the scene of how these agents are created. We have got one more session coming up. Don't go anywhere.
Thank you.
Okay.
Bye.
Bye.